All right, guys, welcome to HideScience.org. Today we're going to be talking about using the IUPAC system for naming, and we'll be writing formulas today of ionic and covalent compounds. When we are writing names or we're doing writing formulas, the thing we must do first is identify, is it ionic or is it covalent? Okay. Depending on if it's ionic or if it's covalent, we have to use a different set of rules. The way we identify ionic is looking for the presence of a metal. So on our periodic table, our periodic table looks something in the nature of this right here. Right, there's this this line. It's kind of a stair-step fashion. Everything that's on this side of the periodic table is a non-metal. Everything on this side of that line of the periodic table is a metal, except for hydrogen. Hydrogen is over here on the metal side, but hydrogen actually belongs to the non-metal family. So if it contains one of these metals, then we know it is ionic. Aluminum resides somewhere in this nature here of the periodic table. It's on the left side of this stair-step line, so it is a metal. So therefore, we know that this compound here is indeed ionic. We are trying to write the name of this since we have been given the formula form. And so we need to look to our rules here. And when we write the name of this compound, it's important that we know ionic compounds do not use prefixes because they always exist in the same ratio. It takes 2 aluminums to bind to 3 sulfurs every time, all the time, as far as I know. That's it. So we don't need prefixes to tell us how they bond because we know they bond the same way all the time. So when we write the name, we just write the name of the metal. So we write aluminum, and then we write the name of the nonmetal. This is sulfur, and then we will change the ending of the second word to IDE. Aluminum sulfide is the correct name, IUPAC name for this compound here. Notice there is no prefixes here, even though there are subscript numbers here. All right, moving on to our next compound. Let's just look at H2O, water. Necessity for life, right? Makes planets habitable. Very important element, or compound, excuse me. Hydrogen and oxygen bond together to form water, but they can bond in many different ways. We have 2 nonmetals. This is covalent. Whereas ionics, we said they bond the same way every time, all the time. Covalents can bond differently. So hydrogen and oxygen can bond to form water. Maybe they form the hydroxide polyatomic ion. Maybe they form the hydrogen peroxide. Maybe the hydronium. Right. There's many different ways the hydrogen and oxygen can bond with each other. So since covalent bonds can bond in many different ways, then we have to use prefixes so that we know which form of the compound we are talking about. So if we're talking about H2O, we have to clearly state in the name that there's 2 hydrogens and 1 oxygen. So we will use 2, or di for the prefix 2. This will be dihydrogen because there are 2 hydrogens, and this would be mono. You wouldn't want to do monooxide, so this will be monoxide. Kind of combine them together. We got the ending IDE instead of YGEN for oxygen, and the mono states 1. So here, this tells us in this specific covalent case, we have 2 hydrogens and 1 oxygen. Because if this was, OH, we'd call this the hydroxide ion, but for IUPAC purposes, we would call this oxygen monohydride. Okay. We use the prefix mono for 1, but we never do that on the first word. So covalent is very simple. We just write the words much like we did ionic, but we just use prefixes so that we know the ratios that the elements will be bonding in. Let's move on to writing formulas. We'll start off with our covalent compound. Let's come up one off the top of my head. Let's do dicarbon tetraoxide. dicarbon tetraoxide. So if we look at this, we see the prefix di is with carbon. So there are 2 carbons. We write this C2. And the prefix tetra, which is for 4, is with oxygens. There are 4 oxygens, so O4. So we use the prefixes to tell us the formula. Now in ionic, there were no prefixes. You just have the names. Aluminum oxide. No prefixes here to tell us what subscripts or what numbers to use as our subscripts. So we got to figure them out. So if it doesn't tell us what goes there, we need to figure out what does. So we're going to use the charges. Aluminum is in group 13. That means it has 3 valence electrons. It has 3 valence electrons. When it forms an ion, it is going to lose those 3 electrons. And if you are getting rid of negative things out of your life is going to become more positive. It got rid of 3 negative things, so aluminum is going to have a charge of +3, or oxidative state of +3. Oxygen has 6 valence electrons. It's in group 16 on the periodic table. To get its octet, it needs to gain 2 more electrons. So if you gain 2 more negative things into your life, 2 more electrons, you'll become -2. Once we get to this point, we can do a little simple shortcut here, and we can say we're going to put the 3 down here, we're going to crisscross these, and put the 2 here. And our final answer is Al2O3. And you must do this every time for ionic compounds, because it does not tell us what to write for our subscript. So just in review, first step, you have to determine, is it ionic or is it a covalent substance? Ionics will always have a metal. Covalents will not have a metal. If you're writing the name of an ionic compound, it's very simple. Do not use prefixes. Just write the metal name, then write the non-metal name, and change the ending to IDE. If you're writing the formula, it is not like we did here. It's not going to give you prefixes. So you have to use these crisscross of charges here to figure out the formula. Covalent, when you're naming, you name it the same way. You write the 2 objects and you change the ending to IDE. However, you have to use prefixes so we know which type of covalent compound we are talking about. And then if you already write in the formula, it is going to tell you in the formula, hey, if there's trioxygen, then there's 3 oxygens. So that's it. That's our review on IUPAC naming procedures. I hope you learned what you needed to. We'll see us next time.